So okay, so yeah, I was talking about how smart contract what's it called? What's it called though? Sorry. So yeah, I was talking about how smart contracts is a set of predefined instructions, right? That trigger certain conditions when certain things happen. So now I can write this smart contract, right? And then what's it called? For instance, we could write a smart contract that gives out a particular token when a particular token has been sent to that and to that smart contract. I'm coming. Let me take this away. I think, you know, let me just take this away to Obsidian back. Okay, yeah. So I think maybe in our next class, we would deploy a smart contract that we can interact with that would give us, a particular token called Sepolia Ethereum, right? So Sepolia Ethereum is a token that you can use to test and interact on the Sepolia blockchain. So basically, you cannot convert Sepolia it to Naira. So for those that would want to, you can't. It's just basically to like test, right? So and simulate how the it actually simulates the Ethereum blockchain basically. So we can use Sepolia it to test this smart contract and test how they're going to be when they're deployed on mainnet, which is the Ethereum blockchain. So maybe in our next class we'll build a smart contract, right? That gives out file sets when we interact with them. So basically, just know that my own kind of address, the address that I control is called a wallet address, right? And the address that a smart contract controls is called a contract address. So when I create a wallet, right, a wallet address is generated for me. But on smart contracts, when I deploy a smart contract on the blockchain, a contract address, instead of wallet address, a contract address is generated. So that's how you're going to use to know the smart contract you want to interact with, right? So let's do this. So just what's it called? Build on the last class. So let me copy this. So because we're talking about wallets here, right? And we're talking about transactions as well. Now let me go back to my wallet that I created in the last class, and let's try and let me quickly go there. Okay, MetaMask. Okay, guys. So now I'm in my MetaMask wallet, right? And you can see my wallet address, right? So my wallet, we can use our wallet. Basically, our wallet are used to store cryptocurrencies that have gone over, and we can also use our wallet to interact with in Web3. Basically, we can use our wallet to interact with Web3 platforms like that Jup.ag that we interacted with, that we had to connect our wallet, right? And I can also use my wallet to interact with a smart contract. So let's do this, right? Let's try and get, because the wallet is to store tokens or store coins here. So let's try and get a testnet token, which will be Sepolia 8. So on MetaMask, I don't know why they did not, when you click on this place on MetaMask, on mobile or even on desktop. Okay, yeah, here we go. So when we click here and we by default, this toggle is switched off by default, so we'd have to toggle it on. So when we toggle it on, we're going to see Sepolia. So we'll click on Sepolia, right? And then um, it's loading. So it's a testnet network, right? So this is my MetaMask wallet, and how do I explain this? Okay, MetaMask, right, is a wallet that is an Ethereum that supports is a wallet that supports EVM. I mean Ethereum tokens or Ethereum networks. So it's a wallet that is used for what's it called? Keeping coins that are it could be Ethereum or other tokens or projects that have been built on Ethereum or network that are built on Ethereum, right? So we can see that, let's click on Ethereum mainnet, for instance. We can see that this is my wallet address. Okay, let's do this. Um, this is just hold on. Okay, yeah, this is my wallet address, right? You can see just know that it starts with OX. My particular one starts with OX and it ends with 632 on Ethereum mainnet, right? Let's check Linear, which is a blockchain built inside of Ethereum, although we'll talk about layer one and layer two if time permits us rather. So you can see that it's still the same thing, right, across the network as far as I'm using this particular wallet. So no matter which network I go to, I can go to Arbitrum one network, right? I can add it by default and approve it here. So I'm coming. It's adding the network. Okay. So yeah, great. So I've connected to the Arbitrum one network, and we can see that my wallet address is still the same thing here because I'm interacting with this what's it called? With the same wallet that I created. So my wallet remains the same, and it's so as far as I want to interact with a network that has been built on Ethereum, I can interact with it with this particular wallet. So let's copy the address and head back to Sepolia Ethereum, right? So right now I have zero Sepolia Ethereum, right? So just picture Sepolia Ethereum as a blockchain built inside of Ethereum, for instance, yeah. So my wallet address still remains the same and I've copied it. Now let me go to this platform. Okay. So basically this is a platform where I can get, okay, no. I copied, I'm coming, let me paste this. Okay, great. Yeah. Sepolia Ethereum. Yeah, so this is where I can get Sepolia Ethereum, right? So all I have to do is remember this is a Web2 platform that integrates with Web3. So that I said one of the things that in any Web3 platform, the main thing is your wallet address to access a Web3 platform. So now for me to get this Ethereum Sepolia, right, the only thing that it requires is my wallet address. So because I put my wallet address, I would just paste it here, and then I'll click on receive 0.05 Sepolia Ethereum. So when I click on this button, um, yeah, so it's you can see that it's a testnet token, meaning that it's not really you cannot spend this token in the real world, and you cannot convert this token to USDC or USDT or whatever token. You cannot swap this token to Ethereum as well. So it's just to test, on the Ethereum network. So it's loading. Just give it some time. Um, okay, let me just ever out to zoom out. So it has a chat button. So let me just paste the link here. So anyone interested would get Sepolia Ethereum, right? So all you have to do by default is not when you create your MetaMask wallet, you would have to enable Sepolia 8, right? So it's a testnet token. So you can use this to get what's it called? Um, um, Sepolia Ethereum, right? So you would really need this if you are building on Ethereum or if you're testing something. So yeah, I think this thing has been sent, right? But now let's look at something. For me to use this platform, I only entered my wallet address, right? And it sent me, and I requested for Sepolia Ethereum, and it sent it to me. Now let's view this transaction on the blockchain. So it creates a transaction hash, which I had to click on. So remember I told you that the blockchain is literally transparent and it is decentralized. You can see everything going on the blockchain. You can see what's it called? All the transactions going on the blockchain. So now let me hide this in a place that's yeah. Oh, uh-huh. So okay, I think it's good. So now I clicked on that transaction hash, right? And it brought me to this page. Now, this is a record How do I explain? Okay, going back to this my drawing that I used at the beginning of the class, right? Where's this thing? Where's Jordan Ohio? Jordan Ohio, Jordan Ohio. Okay, I'm coming, just hold on. Mm-mm. Okay, yeah. Yeah. Where I said that the blockchain, is basically a record keeping system or is a distributed ledger that stores transactions over a network. You get. So each transaction is stored in a block, right? For instance, a transaction 150 is stored in block one, right? And so forth and so on and so forth. So, and when we come here, transaction 51 to 151 to 200 are stored in block four. Now, when we're looking at something, after we got that Sepolia it's bar, when we go back to this place, I'm coming. Okay, this was I was using. Okay, I'm coming. So when we go back to, so I'm trying to find the tab I was using. Uh, should be which tab I'm going to use for this thing? No. Well, okay, okay. Guys, don't mind me. So I just got back to the tab I was using the other time. So we can see that, when we interacted with this, yeah, and it sent us a transaction, it sent out what we called a transaction hash. So it's kind of a place where we can see that a record of that transaction on the blockchain, yeah, like a source of truth, for instance. So in real life, yeah, for instance, where maybe when you send something, maybe OP to OP, for instance, which is usually very fast, or let me say when you send probably money from Access Bank to GT, right? And the person will be like, I never see him, I never see him, those kind of thing. The only way we can confirm is when we go to our banks, right? Because our banks are centralized entity, you get, so we do not have that record available, right? So here on the blockchain, as far as you've sent something to a particular address, right? And let's say someone you know, and the person is claiming he has not seen it, right? All you have to do is just go to click on the transaction hash, right? And then, which is this, right? And then when you click on it, it's going to bring out the transaction and it's going to show you, you know, this is going to show a status called success here, which means that it was confirmed. You get. So the blockchain, because of the fact that it's available to everybody and we can view this, we can literally come here and it's a proof that this transaction was truly sent. So now, yeah, now let's analyze this. So this is the transaction hash. This is the sources indicating that the transaction was successful, and this is the block that it was stored. That I was showing you guys something about the blocks that we keep when I was drawing something out. Yeah, yeah, I'm coming. So yeah, right. So this is an example of blocks, right? I was saying that transaction 1 to 50 is stored in block one, 51 is stored in block two, and so on. So this is the block that this my transaction that we just performed was stored on, which is block 767, blah 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 blah. So we can see that this was a wallet that sent Sepolia 8, 0.05 Sepolia 8 to my address. This is my address. When I go back to my MetaMask wallet, right? MetaMask. When I go back to my MetaMask wallet, I would see my Sepolia 8. Yeah, it was there before. Right now it has incremented by 0.05. Are you guys getting it?
Yes, sir. We're getting it, sir.
All right, Chief. So what's it called? So for any question, and my laptop was some go. Okay. So I want to believe, I mean, that there are no questions for now, right? So now, okay, have anybody created, have anybody so far, have anybody created the MetaMask wallet? And can you send me your address on the chat if anybody have done that? Just send me your wallet address on this thing. So I'm explaining transactions here, and we could see that we perform a transaction, right? So this is me interacting with this particular contract, and it was this platform that owned the contract. So they literally sent 0.05 Ethereum to me, right? So in transactions, there are certain interactions in transactions, basically. So we can interact from a smart contract to a wallet. In this case, that's what happened. I interacted with this platform, right? And it sent Sepolia 8 to my wallet, right? So another way, again, I can do that. Another interaction we can do is wallet to wallet. So I can send Sepolia 8 from my wallet to another person's wallet. So I think with that, I would explain, gas. So when you want to, so basically with gas, right? When you want to, let me go back to Obsidian. When you want to do a perform a transaction on the blockchain, there's something called a gas fee, right? So just like when you want to transfer money to your bank, another bank, and the bank that you want to transfer from is charging you 10 naira, all those kind of things. So the gas is usually charged in the native token of the blockchain. So in this case, because we are interacting with Sepolia Ethereum, the gas they're going to charge me with is going to be Sepolia gas. So let me just quickly, I think that will be the last thing, followed by layer one and layer two. Since my, what's it called? So I think when we go over that, we'd be able to, at least I've gone over the things that we ought to go over in this class. And the next class, we'll be creating a smart contract, deploying it, and interacting with it. So it will be much more fun, right? So let me check the chat. Have anybody sent anything to the chat? Anybody so far? Okay. I mean, because of time, yeah, my battery is really running low. So let me just simulate a transaction here and show you guys something. So what's it called? So MetaMask. Let me go back to MetaMask, right? And let me try and perform a wallet-to-wallet transaction. Since you know that what I performed there was a smart contract to wallet, where I interacted with the smart contract of this platform, and they sent me 0.05 Ethereum. So now, if I want to send um, some of my Sepolia into another wallet, all I have to do is to click on this. All I have to do is to click on this send interface on MetaMask, and then enter the address of the wallet I'm trying to transfer to, right? No, no, sorry. Okay. Yep. This address, which is my address, right? So I'm trying to transfer this wallet, this Ethereum, in this case, Sepolia Ethereum to my another wallet, in this case, my own address, basically. So just to save time. So I can transfer, because I have 0. My balance here, 0.005, right? Let me just transfer 0.01, 0.01 here. So I'll click on continue, right? So now we can see what we call network fee, and we can see that it's charging me 0.0003 Sepolia Ethereum. So basically, network fee and gas fee are the same thing. So just picture it as the fee that is charged when you're performing a transaction. In this case of this smart contract now, it was this smart contract that paid the gas fee, because it's the person that is initiating a transaction that will pay a gas fee. You get. So when I click on this and I confirm it, oh God, okay. So when I click on this and I click on confirm here, it's going to it's going to pend, and then it's going to show confirm very soon. But then you get the point of, of transactions now, right? So now I literally sent this to myself here, and you can see that my balance deducted. You get, I had 0.05 before. I sent one to myself, right? But they charged me 0.003 gas fee. So I had to pay for that. That's why my balance decreased there. So, I mean, so today we've gone over what's it called? The last class, recap. We've gone over cryptocurrency. We have two type of cryptocurrency. We have the native token, which is a token that is usually named after the blockchain and is used to perform governance, decisions in the blockchain. We have coins, which is the tokens of every other projects that are built on a particular blockchain, right? We went over Solana, we went over Jupe. Solana is a native token. Jupe is a token of a project that was built in Solana blockchain. So basically, we went over transactions, we performed a transaction, and we went over gas as well. We also went over, the types of wallets we have and the interactions that we can use to perform a transaction. We saw how smart contracts can interact with the wallet address. We just saw how a wallet address can also interact, perform a transaction with another wallet address as well, right? The same way we can do this is the same way another smart contract can also interact with another smart contract, right? So because of time, we'll be talking about layer one and layer two in our next class. So this would be like 5 minutes in the next class, and the whole of next week would be about smart contracts, and we are going to write a smart contract and deploy it on a blockchain. So guys, I would have to go. I would have to end this meeting because of my laptop, so that I'll also try and save this record as well. So guys, it's been fun. Let me just stop here. So it's been a pleasure being here. So guys, thanks for everyone. Thanks for your time, and see you next week Sunday. Bye.